Okay, having a look at a couple of videos on our probability section in our Unit 2 for maths methods. So we're looking at discrete random variables. To start with, we're going to look at a bit of how to construct some probability distribution tables and also look at expected value and standard deviation and variance for a probability distribution. So a couple of things to start with, a few things to know. So if we have a discrete variable, that means we only have distinct, and something happened to my page there, distinct values there. So for example, we might have 0, 1, 2, 3, ... Whole numbers are our general ones there. So number in a family, number of people doing something, or number of times something occurs. So generally whole numbers. Usually my example for discrete variables is that you can have that one exception to the rule where we have our shoe size, where we can have half sizes, otherwise whole numbers all the way. So continuous is where you can have any values, so you can have decimals. We're focusing on our discrete in this section. So another thing to remember is if you have a probability distribution, it has to add to 1. So, or you might be given percentages, so then it would have to add to 100%. So you can be asked to check if something is a probability distribution, and that's where you'll add up the probabilities and check what they equal to. So in this case, we've got 0.05, 0.35, 0.55, and 0.15. When we add them up, we get 1.1. So we can say, no, this isn't a probability distribution. If we got 1, then it would be yes. If we had percentages and we got 100%, yes, it would be a probability distribution. Another thing to note is when you are writing a statement, so you're trying to write something that says the probability of x is equal to 2. This is how we can write it, where we have PR outside of x equals 2. You might also see it with just the p, and I will often fall back into just writing the p because that's what I'm used to from when I was at school, but we have converted to writing the PR in front, but just be aware you might see it with the p. Having a look at an example with a table now. So we've got our little example here where we have some numbers and we've got one missing. Now, if we know that it's a probability distribution, we can then work out what the missing value is. So we'll grab our calculator, we'll add those ones up. So 0.3 plus 0.2 plus 0.2 plus 0.1 plus 0.005, and we get 0.805. So then to get that missing value, we can do 1, take away that answer, and we get 0.195. And I've just realised I put in an extra 0 up here in my line of working. So I put 0.005 instead of 0.05. So I'm going to bring that down, take out that extra 0. I'll get my 0.85 and then do my 1, take away my answer, and I get 0.15 to go there. So always checking those extra zeros. Don't slip into your calculator typing. Now we can be asked then to find the probability that x is equal to 5, which we've just done there, and we can put that in as our answer. We can also be asked things like find the probability that x is greater than or equal to 1 and less than or equal to 4. So because it's got the equal bit there, that means we are including those ones. So we've got 1, 2, 3, and 4, and we're going to add those values together. So we'll grab our 0.2 plus 0.2 plus 0.1 plus 0.005, oh, 0.05, sorry, did it again. And we get 0.55. Then we've got here that x is less than 3. So that means it's not including the 3 because we don't have that equal sign there. So we're just going to grab the 2, 1, and 0. So we've got 0.3 plus 0.2 plus 0.2, and we get 0.7 for that answer. So just being really careful when you look at them. Is it including or not including that value? Has it got the greater than or equal to, or just greater than? Then we go on to one where we haven't got the probability given to us, but we've been given some information about the distribution. So we've got these lines of numbers here, which are our number of households, and here we've got our number of teenagers in the household. So first we want to find out what the total is there. So we're going to grab 2570 plus 237 plus 76 plus 14 plus 3, and we get 2,900 all together. So that means we can then work out our probability by doing our number that we have divided by the total and finding out what that's equal to. So I'll grab the 2570, I'll divide that by 2900, and I get 0.886. Then I've got my 237 divided by 2900, and I get 0.0817. So I'll round that to 0.082. Then I've got the 76 divided by 2900, so I get 0.026. And then I've got the next one, which will be the 14 divided by 2900, which gives me 0.0048, so I'll round that to 0.005. And then my last one, I can either grab these four, add them together and take them away from 1, or do that 3 divided by 2900. I get 0.001. And then I'll quickly check that they add to 1, and I might have had to like round differently there. Hopefully it works out. Plus 0.082, plus 0.026, plus 0.005, plus 0.001, and it adds to 1. So that worked out well. So then I now have my numbers there. If I wanted them as percentages, I would times them by 100. Makes me feel very rare there sitting with 4 teenagers in my house, only 1%. Or so only 0.1% of people have that many teenagers in their household. So I definitely am in the minority. In the next video, I'm going to go through how we can use a tree diagram to complete a probability distribution table.